So Jeremy, I didn't realize you were doing the women in physics lesson.
Yes.
Fantastic. I'm glad I'm here. I have not yet presented women in physics. I've been doing careers in physics. So this is fantastic. Thank you.
Good.
Yeah, no problem.
So it's 5 p.m. for me in Chandler, Arizona, and I would like to welcome Jeremy for hosting another Step Up meeting, and I'm hoping that Melissa will be joining us any minute now. The session will be recorded, or is already being recorded, because there's a few people who are not able to join us today, and all the recording with slides and everything else that may be available to share will be posted on the membership portal for later access. So without further ado, Jeremy, floor is yours.
All right. Thank you. Thank you, Wendy. So we are here today for the Step Up Women in Physics lesson. Step Up is a program, a joint project from APS, AAPT, Florida International University, National Science Foundation, and Texas A&M Commerce. And the program's been around since 2018. It's gone through some large revision and then like some small tweaking over the last couple of years. And I've been involved with the program. I started doing the lessons in 2018 when they first came out, and I've been a Step Up ambassador now for 2 years. So there's me, and I think I know everybody who's here on this call. Hopefully we'll get Melissa in here soon. Melissa is a fantastic teacher from the Phoenix area. She is currently the AMTA vice president, I believe, and also a Step Up ambassador. So I'm just going to jump right into it then. So we want to think about women in physics in the United States. And so first, I just want to give you an overview of like, why does this project exist? What are we trying to accomplish here? And so if we look at this graph, these bar charts, about percentage of women in chemistry, biology, and physics at different stages in academia. What do you notice there as far as any trends go? Comparing 3 disciplines of physics, chemistry, biology, comparing different stages in life, high school, entering college, bachelor's degrees, PhDs. What do you notice?
It looks like women are taking it in high school, but not very much afterwards.
Women are taking it, you're referring to physics.
Physics, yeah, sorry. That's what I teach. So sorry.
Right. And so we have women studying physics in high school and then not so much beyond.
Yeah, it falls off almost, it's less than half, it looks like.
But what does this graph look like for men? If men are taking physics in high school, or for all that for that matters, with the other sciences, do they have?
Well, what it looks like for men is the remaining up to 100%. Because
Okay.
this is the percentage of who is enrolled who are women.
Yes. Oh, so okay.
So if we're at, say, 25% women, then the other 75% are non-women. So, close to 75% men.
Okay.
And also maybe we noticed that the same drop-off doesn't really seem to happen so much with those other sciences. Maybe a little bit at the high end with chemistry, but by and large, like this looks like a physics issue more so than other sciences. And so even though women make up nearly 50% of enrollment in high school physics, we've got less than 20% of our post-secondary physics majors are women. And so Step Up, so we're taking the approach of, like, this isn't satisfactory. We're not happy with such a low percentage of women in physics, and so we want to do something about that. And we want to draw on research. We want to use evidence, because of course, this is physics, and we care about evidence, and we use research. And so we want to get thousands of high school physics teachers across the U.S. To work on this problem with us, to reduce barriers for women to pursue physics degrees, and to change the cultural views that we have about who does physics and what good is physics for. And so we just want to change things at the high school level, because we feel like high school is the right place. And I think I'm going to come back to that in a few minutes, but high school is the right place for us to do this work. And so our goal, looking at these low percentages of bachelor's degrees being awarded to women, our goal is to reach 50%. Because if 50% of the people are women, then 50% of the people in physics should be women. And so it's a long climb to get there, but if we don't aspire to that equality, then we're not going to get there. So that is what our mission is. So why high school? For one reason, women physicists who are interviewed responded pretty overwhelmingly that was the time in their lives when they first started to really feel like physics was the thing that they were interested in. And also, compared with elementary school, the high school physics teachers have greater content knowledge. We're more invested in physics, and that those students in high school are closer to making decisions about their futures. In college, we have larger classes. We don't have as many opportunities to build relationships between professors and students, and so it feels like younger grades and college are going to be important parts of the story, but high school teachers are the likeliest, biggest source of making change now. And so we've got 3 different things available for free at stepuphysics.org. There's a careers in physics lesson, women in physics lesson, which is our focus tonight, and the everyday actions guide. The careers in physics lesson, which anybody who hasn't learned about that one, I would certainly be happy to talk your ear off about it anytime, and I'm sure Nicole would as well. The careers in physics lesson is something that I do very early on in the school year, where we explore who does physics, or what can you even do with a physics degree, because students do not have a clear concept of what can I do with a physics degree. And so we want to make clearer that that physics has value to communities, value for humans, and we can do good in the world with physics, and we can exercise all kinds of different skills and creativity with physics. And the women in physics lesson specifically is about why are there so many fewer women than non-women in physics. And the everyday actions guide is just a set of guidelines to help us steer our own thinking about maybe some of the conscious and unconscious decisions that we make in the classroom. Who do we talk to about what on a daily basis? Just to sort of a self-check to help us think about what we're doing on a daily basis. And you can go to stepuphysics.org now. You can register for Step Up. And it's a strange registration process, because in order to register for Step Up, first, you have to make an APS account if you don't have one already. And then after you've got the APS account, then you can register for Step Up. So it's like a 2-stage process. But certainly feel free anytime to go to stepuphysics.org and register. You get access for free to all of those materials, all 3 of those components, the 2 lessons, careers in physics, women in physics, and the Everyday Actions Guide. Plus, there's a forum where people can talk about, how do you do this? What about when you encounter that? And also, there are guidelines for like ways to do this remotely, which certainly are helpful right now. So diving into the Women in Physics lesson, and you can see there on the right side of the screen, like if you log in after you register, then you can find, like presentation slides, you can find PowerPoint, you can find the poster that we're going to look at, you can find files for your students, all of these things to download.
Jeremy, I just
Yes.
messaged Melissa, and she said that she's not having any luck joining the Zoom. So she was trying to get in, but she can't get in.
Interesting. Wendy, can you communicate with Melissa to help her find it?
Thank you.
I already sent her the Zoom information. I have no idea why she's not able to get in.
Oh, here she is. She's coming in now.
Oh, yoo-hoo!
Yay. So in the Women in Physics lesson, students examine the conditions for women in physics by, we start off by researching famous physicists and analyzing trends and stereotypes, talking about gender issues regarding famous physicists, looking at data all around the world, and the last point there is one of the most important, and I'm definitely going to talk a lot about this one soon, talking about personal experiences. And I want to stop right now and welcome Melissa. Melissa had some trouble getting in, but she's here now. Melissa, do you want to introduce yourself?
Hi, everyone. I'm Melissa Grimstein. I am a physics teacher in Phoenix, Arizona. Sorry about that. I had the wrong link saved in my calendar. My fault.
No problem. And Melissa, since you were going to be talking about these, do you want to jump right in, or do you need a minute to get your bearings? Or
I can absolutely do this. This is pretty fun because I actually ran this with my students not too long ago. So yeah, we started by having them examine. I have them type in famous physicists, and so they were able to kind of look and see what pops up. So as part of that, we did want to, these are the critical components that researchers and master teachers have determined are pretty crucial to this particular lesson. And so one of them is to establish these discussion guidelines, and Step Up does have a free poster download with these guidelines in there. We do want to make sure that they look at some data comparing what might happen for physics career choices, depending on a student's background. And then we also want them to be able to share some personal experience as it relates to gender and science, physics specifically, but maybe science in general. My students are freshmen, so for them it was science in general, and they actually gave some really great feedback in that. So these are the three things that we really want to make sure as far as leading the lesson with students, that these are kept in, because research is telling us that these are those effective pieces. And then we have some lesson performance objectives as well. And we're going to kind of go over those as we go through. So if you want, we can head on to the next one. Right, so these are the key steps in the lesson. The students are going to start by doing some background research, basically just into famous physicists. We're going to have them read two biographies of historical and modern physics and compare it to a reflection. So they might not find the ones that they are reading about in their initial search. And that's the whole point of this one, just have them look at somebody that they might not normally find in a search. We do have them go through then the classroom guidelines. These are guidelines for discussion. They're great to use in the classroom. We are going to have them participate in some sort of an interactive presentation. Now, interactive could look differently, whether it's in person or remote, and looking at data on women in physics from all around the world, and talking about unconscious bias. Then we do want to have the students This is why the critical component for classroom guidelines is in there. We do want to have the students look at gender bias and talk about their own experience within the classroom. So we're opening up really to a sensitive conversation. And so I've tried this even with freshmen. I'll tell you that sensitive conversation, they had some great insights that even I hadn't thought of as a 14-year-old. They had great insights on how bias might affect them. And then they're going to come up with some strategies to support diversity within physics and complete a reflection on this. So this is a great dig into kind of what they know, why they know it, and what they've experienced. So the first step that I did with my students, I had them type in famous physicists, and I told them just Google just this. I'm going to type it in. We did this remotely. I put it in the chat, famous physicists. I said copy and paste this. And so I had them hit, and I said, what? I just want you to look for a moment. Now what do you see? And 14-year-olds, bless their hearts. They're all old white dudes. This is what I got back from them. They're all old white guys. And so they had to, when they look at Google, they could kind of scroll to the side, and I say, well, tell me, I want you to scroll. Tell me when you reach somebody that's not an old white guy. And there was a pause, and a pause, a pause, and I went, now I found one. So for them, right away, they saw there's something up with that. There's something, and a few of them express some concern that this is what they always see. They kind of like, this is what they always know about science. And so after that, they read now 2 articles on physicists they might not have found in their search. And so by looking at Lisa Meitner and Jocelyn Bell Burnell, they were able to see 2 very accomplished women physicists. And they were pretty fascinated by pulsars and just the whole idea of pulsars. And the fact that this woman is still alive, they were pretty excited by this. So we were able to contrast what they see from 2 famous women versus what they saw in the search. And they were very concerned they didn't see the women in the search as well. So this is all part of the pre, and then they're going to read one of the articles on one of these physicists, so Claudia Alexander, excuse me. We're going to see a list of physicists that may not necessarily pop up in their mind as physicists. Now, talking nuclear fission and pulsars, my students right away, well, that's a physicist. When I started bringing in someone who works on Wall Street, or someone's been to space, they're like, wait, that's not a physicist. Like, well, who does physics? It was a very good lead into a conversation of who does physics. Do they have to necessarily be someone who is talking about nuclear fission or pulsars? And so this was all part of a pre-assignment that we did with my students to kind of lead into the part that we're going to talk about next. So yes, we did do this asynchronously. I had them read it ahead of time. So we did kind of the search at the end of one class, and then they were assigned the readings and then come in the next day. So it does work remotely. All right, so then from this is where we get into where they're going to look at some of the things that they saw. I wanted to bring them back, reminded them what did they see when they looked at the search. And then now we looked at women in physics around the world. This is very much going to lead into kind of a sensitive topic. My classes, because I have freshmen, they are fairly equal split of female and male students. They're I will say they're a very diverse group. Actually, my school is only about 20% white. So I have students from all over the world in their class. So I knew right away this is gonna be great potential for them to not only talk about gender, but also talk about some bias in terms of race, religion, ethnicity. So, and they did not disappoint. This was a great lesson for bringing those particular issues up. So this is from the guidelines for classroom discussion, and we encourage students to share airtime equitably. And we did spend some time talking about what that means. And so this is a great one to bring up with students. they would share their airtime equitably. They right away said nobody's going to hog the conversation. That was their comment. We asked them to, you know, go ahead and click, asked them to value. I said, what are differences? They knew that not everybody's going to have the same opinion. Not everybody has the same background. And so we had to make sure that we were going to promise to honor that ahead of time. Big one, argue using evidence. We've been doing this all year, so I reminded them, if you're gonna say something, you gotta be prepared to back it up. We did talk about how make sure everyone feels safe. What exactly does that mean? That we knew that we weren't going to attack anyone, that we knew that we would value everyone, that we knew that we valued everyone as a person, as a scientist, and as a learner within the classroom. And I did remind them sometimes you're going to feel uncomfortable. And it's okay if we feel uncomfortable because that's when we learn. And finally, the last one is to own your impact. And so talking about with them, we discussed that everything they say could influence someone, could impact how they feel about themselves, could impact how they feel about the world around them. And they needed to be aware of that before they were sharing anything. And so these discussion guidelines are stuff that a lot of step-up teachers use within their classroom. I have one of the posters hanging in my room so I can remind students to come back to it. And actually, I start this earlier in the year, separate from this lesson, so that we use these discussion guidelines. We just kind of refine them and using what we learn about each other, and we can work with this throughout the year. All right, and again, this poster is available for free download through StepUp. Bonus points if you get it in your state's House of Representatives.
Yeah. And then Melissa, is this?
I think that was the breakout we were going to.
Okay, yeah. So at this point, then we would start like a PowerPoint, something like that, an interactive presentation. The teachers got some data to share on women in physics all around the world, and we're going to have a discussion in class. So like this is something that normally I would do in class. This year I did it over Google Meet, which was less, well, I did get some really good interaction in the chat, but you know, not quite the same as being in person. But this was something I felt I needed to do synchronously when I could. So we're going to have conversation about physics degrees awarded to women, academic achievement, unconscious bias, and gendered professions in this conversation. So I want you to engage in student mode. And everybody here has some degree of experience, at least with modeling. So we know student mode, you know, we're pretending that we're the teenage versions of ourselves. So, you know, answering as the 16-year-old version of you, which science field do you think has the highest percentage of women in it? And you can just put that response, you can put your response in the chat if you like. And for some reason, the chat won't show up when I click. But I would love to hear, since it doesn't want to show up for me, then either Melissa can shout it out if she can see what's in the chat, or you all can shout it out.
I'm seeing 1 vote for chemistry and 4 biology.
1 for chemistry, 4 for biology. Okay, cool. Which do you think maybe has the lowest percentage of women in it? And you can just put that in the chat.
So 3 for math, 2 for physics.
3 math, 2 physics. All right. Some people believe in us. All right. Well, you know, you've been in my class all year long. You know, I'm going to have data. Would you like to see some data? All right, because I'm always going to show up with data. So looking at this graph, so at first there's probably a lot to look at. But if you look at, so we're looking at over like the last 50-ish years worth of bachelor's degrees, and looking at the dashed line near the top, that's all bachelor's degrees. So 1967, we started off with just over 40% of bachelor's degrees going to women, which is, we would expect that to be around 50% if women are about 50% of the population. And that number steadily grew and grew and grew and then leveled off in the 2000s, but leveled off at over 50%. That's interesting. And we can see there, we can see that a bunch of these specific fields also rose over that same sort of time period. And then it looks like a lot of them leveled off also. So we can see there, the brown at the top is biology. So those of you who thought biology, turns out that you were right. Although those of you who picked chemistry, you had good reason to think chemistry because it's a solid number 2 there. And then we look for physics is red, and physics is in like the saddest race to the bottom with engineering so physics not doing so hot. Math is actually not as terrible as maybe we imagined, but math could do better, but we definitely want to focus in on physics because A, this is a physics class after all, and B, physics is not showing us its best right here. So a key question to me, remembering that you're 16 years old right now, why, thinking back to these stats that I personally think look pretty ugly for physics. So why are women better represented in some fields and not so well represented in other fields? Like physics and engineering, we don't see women there, not nearly as many as we should be seeing. Biology, chemistry are doing so much better. So what reasons can you think of? You can just go ahead and unmute yourself and offer up any possible explanations that might explain why we don't see so many women in physics and engineering.
So this is just for the possible chemistry and biology bump. Is medicine included in those?
Well, these are undergraduate, these are bachelor's degrees. So, we'd be looking at degrees maybe that people are medical degrees here.
Okay. Well, you know what I mean? They were just possible medicine-oriented students.
I feel like a lot of students that go into university thinking they're going to go into medicine start with biology.
Yeah, that's what I meant. So.
Mm-hmm. I suppose a follow-up question to that would be, why are women steering towards medicine specifically? If we think that might be a reason why, then the follow-up to that is, then why are women so strongly gravitating, towards medicine?
Is it possibly that medical fields lend themselves more to caring for others and females are caregivers?
So it's possible that women are steering towards chemistry or biology because they're interested in medicine, because we see women as caregivers, and being a doctor is a caregiving kind of role. That's one possibility. What else are we thinking? Why might we see women better represented in some fields and not so much in, say, physics and engineering?
can't really say that women who graduate or who have a bachelor in one of the sciences will become teachers. And there is a bigger need for biology and chemistry teachers because it's biology first, then chemistry, and then physics. Maybe. But of course,
so
you can do a
maybe-
whole lot more with a degree, but.
So what I think I'm hearing Wendy saying is that maybe because women are steering towards roles as teachers, that they're working towards degrees in teaching fields that are more in demand than physics. Which, that's an interesting thing to me because, again, so what Wendy brought up matches up with what Mike and Nicole were talking about those caregiving kinds of roles. I think that's interesting. I'm gonna, oh, I'm sorry, go
I was
ahead.
gonna say, I'll tell you, it's funny. I just turned 50. Don't tell anybody.
And you're still in high school? That's weird.
I know. My husband is an engineer. And even when I met him, I had to ask him, what exactly do you do? When I left high school and started university, I literally thought an engineer drove a train. And apparently I wasn't wrong, but I lived in a community where there were not engineers. It wasn't exactly rural, but it was pretty rural. And so I did not even know what engineering was. And so it wasn't even on my radar.
Interesting. So I want to refocus the question just a little bit to maybe what are some things, not necessarily that you think might be true, but that maybe somebody else in the class or somebody you know in the school, because remember, you're 16. Somebody else in your school or somebody else that you know in the community, what might they think? Even if you don't believe it's true, what might somebody else be thinking about why we don't see women in physics or engineering?
All the physics teachers at my school are men, so physics is for men.
You see people doing physics who are men, so you think physics is for men. Other thoughts on why somebody, even if it's not you, might be thinking that we see fewer women in physics and engineering?
Boys are better at physics than girls.
Boys are better at physics than girls.
Mhm.
Anybody else in the class ever hear any thoughts that match up with something like that? Whether you agree with it or not.
And they're also better in math. And I hear there's so much math in physics, so I better just stick with chemistry.
So whether we agree with it or not, we've heard these things. And I want to step out of student mode right now because, you know, this could last for a while and we've got a lot of stuff to think about tonight. But essentially where I want to take that conversation is big picture. We've got cultural reasons why, we've got biological reasons why that somebody might think is the reason why we see fewer women in physics or engineering or other, you know, mathematical based fields. And so we want to explore, you know, like, and so, you know, right now we would want this as like the question, you know, like, can we find some evidence? Because again, we're doing science here. Evidence that could maybe help us answer, because there are a lot of people who identify cultural issues surrounding people's career choices. And there are people who think of biological reasons. And I'm visualizing one very specific person right now, you know, like, you know, I have had students in my class who very strongly believed that this is a biological phenomenon. Now, you know, I don't want my students ending up there, but, you know, like, there are students who believe this and will say so, and there are students who believe this but won't say so because they know they're not supposed to say it. And so, you know, it can be hard to draw that one out because, you know, people know, like, I'm going to get in trouble if I say this one. But we want to set up, you know, like, is this cultural or is this biological? So let's take a look at some data. I want you to choose then, which of these countries, Germany, Argentina, Iran, or the USA, which of these countries do you think is country A that has 60% of its undergraduate physics degrees being awarded to women? And you can just put that in the chat. And since I can't see the chat, then Melissa hopefully can tell me what you're thinking right now. And you're not going to get punished or rewarded for being right or wrong. I'm just curious what your thinking is right now. Like, what would be your best guess? Which country is the highest at 60%? Germany, Argentina, Iran, or USA?
We have 2 votes for Germany and 2 for Iran.
Interesting. 2 votes for Germany, 2 votes for Iran. And which of these countries would you guess has the lowest percentage? Which is country D?
So 4 votes there for the United States.
All right. We do not, as I distinctly remember one student putting in the chat in our Google Meet when I did this with my students in December, we do not stand the USA. Using the language of our kids. So you'd like to see some results? You'd like to know which country is which? Well, here we go. So important things to notice. Number 1, you know, USA, you know, we're not last. We're not last. At 20%. Although Germany, and a lot of people expect Germany to be way up there, and Germany is at 19%. And I'll point out that, you know, like, we shouldn't be that excited about being at 20 versus 19. That's basically a tie for terriblest. Canada, really, Australia, not really doing much better. And Iran is surprising to a lot of people. Iran at 60%. Wow. I also want to give a special shout out to Albania. A strange thing, strange to me, I guess, culturally speaking, because it's not what I'm accustomed to. But apparently in Albania, when you go to university, you don't choose your major. Your major is chosen for you based on your prior academic record. So Albania is a place where you don't get to choose what your field of study and university will be. And we've got a 50-50 split, women and non-women. But what a surprise for so many of us that Iran is way up there at 60%, and Germany way down there at 19%, USA pretty much tied with Germany. And so we want to know, like, what is going on in these different countries that lead to such different results? What's happening in Iran that leads to such a high percentage of women studying physics? And a study from a couple of years ago showed that families are making the conscious choice to invest in the education of their girls, and there are national policies in place supporting girls studying physics. Boys also are just finding other things that they happen to find more interesting. So we're getting fewer boys entering the field of physics at the same time that we've got, both at the family and national levels, we've got people pushing the education of girls specifically in physics in Iran. Now, if we contrast that with Germany, women take the primary role in parenthood. Women's accomplishments are underappreciated. Women are underpaid, which I'm not a woman, but I know I have a lot of friends who are women. I'm married to one, and this is something that I hear from all of the women in my life as also issues in the United States. women taking the primary role in parenthood, underappreciated accomplishments, underpaid. Also in Germany, they're only now considering recruiting women into physics at the secondary level, like, oh, maybe we should do something about this 19%. And so there are very different things happening in the two different countries. And I'm curious then, what could we take from that information that I just shared with you about women in physics in other countries? What could that suggest to us about possible answers to what we were wondering before about whether women's participation in physics in college, whether that's a cultural issue? We were talking before about like maybe it's sociocultural, maybe it's biological. Do we have any evidence for or against either of those? Is there anything that we could see in this chart with what we know about what's going on in Iran, with what we know about what's going on in Germany? Anything that could support or refute either of those ideas of sociocultural basis or biological basis for why do we see differences? Why do we see in the United States so few women in physics? Is there any evidence one way or another?
Too many choices?
I'm sorry?
Too many choices. You can select any degree. Why select a degree that you know is going to be difficult? And if you look at Albania, if you take the choice element out, it is 50-50.
So if you take out the choice element, then it's 50-50.
Yes. And there's just so many options in the United States. So as a student, I will just take something that I either like or that I know that's not going to be too difficult, that I know that I can do it.
So would that suggest that evidence for or against sociocultural reasons, evidence for or against biological reasons?
Socioeconomic, I would say. You take the choice out. I don't know.
You know, I had gosh, we had a good decade in my community where we had a lot of Albanian students. And I had a top-notch student about 8-10 years ago who went to university, and he was on the fence between becoming a doctor or becoming an engineer. But he ultimately wanted to be able to go back and help his community. And he said, back in Albania, if you were a doctor, you didn't make very much money because you only made money if people could pay you out of their pocket. But an engineer, they really made money. And he thought, if I'm ever going to go back to Albania and support my community, I need to be an engineer. And I just think that for some of these folks from other countries, that's got to be in the back of their mind. What can I do to support my people and what is going to be beneficial there? And that just sort of comes into mind as you're asking these questions to me.
Mm-hmm. And so the thing that I want to zero in on with my students in this, though, is we have ideas and we know that whether we do or don't agree with them, that there are people we know who think that it's biological why we see so few women in physics. And we have ideas that we see fewer women in physics for sociocultural reasons. And so there is evidence here that I want to be able to point out to. So first of all, like Wendy brought up, that when it's chosen for you based on your academic record, it's 50-50, is a really strong argument against biology. And I'm going to make that clear with my students. If it were a biological thing, then we wouldn't see 50% of Albanian women getting, or 50% of the Albanian physics degrees going to women. Also, we have some widely different cultures listed. These different countries have very different cultures. And if it's a biological thing, then why do we see a factor of 3 on this chart as far as how many women are the physicists? If it's mostly biological, then these should be mostly the same percentage across one society to another society. There's lots of evidence here against biology. And I'm going to make that as clear as can be. And there's plenty of evidence for culture then. And thinking about like the evidence, what's the difference between Iran and Germany? Like culturally, we have really, really different situations. And so we can see then that like there are reasons to think that this is a cultural difference in terms of who's studying physics, not a biological difference. And to me, it's key to make that point. And so then, and we've got to move pretty quickly. But so this is some conversation that that I would have with my students. We're not going to go through that, but, we discuss, do we think that there are gender differences in terms of high school grades in high school, in college? And if so, why do you think that? My students tend to expect no difference. And it's also true that men and women get basically the same high school and college physics grades. And when we do see small differences, we see small differences, and they have a lot more variety between countries than they have between genders, which again is pointing towards these are sociocultural issues, not gender issues as far as academic performance. And when we do see small grade differences, that they could happen due to bias. And so, then we can talk in class, like how do we get bias in physics grades? And then that leads us into some conversation about unconscious bias. And some students are ready to accept this idea and some students are not. And it takes a little bit of talk, I think, about this, about unconsciously sorting people without even realizing it. And like something I like to do here is to talk about like a personal story from my life as a parent. I have 2 children and they both are girls. And when they were 5 and 3 years old, in the 2 minutes that their mother and I weren't paying attention, the 5-year-old cut the 3-year-old's hair. And so, and it's a rite of passage if, you have children, but the amazing thing that I share with my students is that then the 3-year-old, because she had like this jagged hair, like we got her a haircut and it was cut really, really, really short for the first time in her life. And something I noticed then the next time that we went out in public is that the way that random strangers talked to my children, which is weird that random strangers think it's okay to talk to toddlers. But aside from that, like I heard people talk to my 3-year-old in ways I had never heard people talking to my children before. Because up until that moment, all the talk when strangers would talk to my children, like, oh, aren't you so pretty? You're just the cutest. You're going to be a little heartbreaker someday, aren't you? And then when one of my daughters got a really, really short haircut and was wearing clothing that didn't obviously identify a gender, like she was walking up some stairs in public and some guy's like, oh, aren't you so big and strong? And it just floored me. Like just the way that people talk to my children has everything to do with the gender they perceive my child to be. And no amount of parenting on my part can take away the fact that my children are growing up in a culture, in a society, and that society is going to impose its expectations on all of us and imposes those on me. And so I might not even be aware of the ways that I just have built-in expectations based on what I see in a person. So I like to use that story just as a way of personally connecting to how we're all immersed in a society, and we can't escape the fact that we have all grown up in a society, and we're not always even aware of the ways that shapes our perceptions. And then, of course, after hearing that, it's no surprise to my students that, like, children by age 6 already have built-in ideas about gender. And this, to me, this one here is so sad to me that, by age 6, girls are less likely to believe that members of their gender are really, really smart and avoid activities associated with being really, really smart. And so, culturally, like this, from the time that they can interact with other people, children are getting these messages. And then we can have some conversation about gendered professions. Why do we think women appear in particular science fields more than others? And there was talk earlier tonight about about roles of being a caregiver. And, we have cultural issues surrounding caregiving and, who should be the caregivers in a society. And talking like, what genders are your doctors and nurses? What about other professions? And so, the goal of the conversation here is just to recognize that, like, people have built-in expectations. When you hear like a profession title, we tend to have built-in expectations about some of those professions and what gender does that profession. Like an example I used is cops. And the same thing with cops and nurses. Like I hear, not nearly as much now as I did, even 10 years ago, but like the term male nurse. The term male nurse implies that we expect nurses to be women. They're just nurses. Or the existence of the term female cop or lady cop. Like, a lady cop pulled me over. Like, oh, what you mean is a cop pulled you over. Because cop is another term for lady cop. They're all cops. But the existence.
Could that be a language thing? Because, well, a doctor, so I'm Dutch, I'm from the Netherlands, so a doctor in many languages, well, no, it's not just in Dutch. So for me, the word nurse is because English is my second language and nurse is a female, but in Dutch, in my language, we have a different word for a verpleger and a verpleegster. So it has a little different ending, and that's the same thing for a police officer. We also have, so in different languages, you have different, the way you say the word, it implies the gender.
Genders, yeah.
So you have maestro and maestra, and professor, professora.
We don't have
Right.
gender.
No. So could that be?
Well,
could
I
that
think
make a difference.
Honestly, no, because we had male men forever.
Okay.
Now it's the male
Right.
person. There's so many careers that was just assumed that it was a woman or a man.
Mm-hmm.
And now we've made them gender neutral, and it's awkward, actually.
Well, so we would have a fireman, and now also it's a fire person. That's the same thing here in English as we have in Europe.
I think there's
and I want to move on from this because we only have a few minutes left.
Yes.
And this conversation could take us the rest of the way through. But there are, in the United States, in English, there are gendered expectations built into our language about who we expect does these roles. And so, that's a conversation we can have, like, what genders are your teachers? Why do we think this? And why do we see this? Why does this happen? And at the end then, I want to do two things after all of that conversation. I want to have a conversation about, so first we're going to talk about these things that we have discussed, and then the critical component, where students are voluntarily contributing their own experiences with gender bias in a discussion with the class. And this, to me, is such an important turning point in the dialogue, especially for the boys in the class. And this, to me, really matters because we are not going to solve issues of gender by waiting for women to solve it. And if we don't get men to understand their role here, then it is going to forever be such an uphill climb. And for the boys in the class to hear their peers talk about things that have happened to them in their school makes such a tremendous difference in the boys shifting from, well, I'm not sexist, so this isn't my problem, to this isn't right, and we need to make change in how we treat each other. And that, to me, is essential. To hear students talk about how, like, I had a student talking in December about how she was in an accounting class. Okay, it's not physics, but it's the same theme. She was in an accounting class where, it was her and 12 boys in the class. And the boys and the teacher all gave her the impression regularly that she didn't belong there. And, like, the boys would, like, she would have a good idea that turned out to be, like, the right answer or whatever. And the other boys would be dismissive of it. And it made her, and she told the class, like, it made me, I was interested in accounting, was thinking about it as a career, and now I want nothing to do with it. And that's powerful to hear. And that's so important to hear. And so to have that dialogue, I also think it's important to give kids a chance to answer anonymously. So if they're, writing on paper and turning in the paper, or this year I did it on a Google form, submit this on a Google form so that, a student who doesn't want to have this event associated with them personally, like other students looking at them as like, that happened to you, they don't want the attention, to have a chance for anonymity there, or for students to just share, this happened to me. And that is such a powerful moment in the class when the students are sharing their experiences. And this is one of those critical components. There are things you can change to tailor to you, to your personality, your teaching, your students. But those critical components those are the things that we feel have got to be there for this to be effective. And then the lesson closure, and this is so important to me also, because up to this point, it's all really depressing, right? It's really upsetting to me. But we want to close on a positive note. And so we want to have some conversation. We want to talk about, okay, what can we do to make change? And I don't know about you and your students, but I've got a ton of students who really care about making the world better. And this is a great time for us to talk about, like, what can we do to change to make this better, and to come up with some specific strategies for, like, how can I be part of the solution rather than part of the problem? What can we do as a class, as a group, as individuals to support diversity in physics? And so that conversation can really turn it towards the positive, because there's something we can do about this instead of just being upset. And then there's a post assignment that you can, it's with the Women in Physics resources, post assignment just to get students writing about their views, thinking about, like, have my views changed at all? So there are remote suggestions at stepupphysics.org/women. And again, if you haven't registered at stepupphysics.org, definitely feel free to do so. There's the online community where you can ask questions and get answers. I want to point out that we see gains in students' intentions, like, yes, I want to study physics in the future, for all students. Higher for female than non-female students, but all students actually benefit from this. So it is 8 o'clock. It is 8:01 right now, and I don't want to hold you any longer than you want to stay. I would be happy to stick around for a while and talk about what can we do to support you? What do you think would work well here? What would be difficult to implement in your classroom? Because some of these conversations can be difficult, especially when you don't know what's a student going to say. But we are very interested in doing what we can do to help you navigate how to implement this in your classroom. So any questions or concerns or thoughts on how this would work for you or could work for you, I would love to hear from you.
So have you generally found the males in your classes to be very supportive of this lesson?
Yes. I've had a few who were stubborn about it. And a few maybe, well, there's one in particular I'm thinking of who probably didn't change his mind, but he at least learned to shut up. And I've had a lot of boys like really change their intent around how they interact with the girls in class.
I would say even with 9th graders, it ran really well with especially the boys in my class. Like, we started talking about sharing stories and they got really upset. I don't think they realized some of the experiences that their classmates had been through, and they were really upset. It was very heartwarming to hear them how upset they were, and they kind of wanted to fix it like right now. So it went really well with them.
I feel like I could do this with my freshmen more this year in physical science, in hopes that then when they are juniors or seniors, then they maybe would take physics, because I'm not sure with my physics students right now how well it would go. At the beginning of the year, next year, I think I could do it, but I definitely think I could do this with my freshmen.
Awesome.
Yeah, I think the way this is laid out would be ideal for my classroom. Yeah.
Brenda, have you tried the careers in physics lesson?
No, I haven't. This is my first lesson or into step up.
I honestly think that the careers in physics is a nice segue into making things more equitable for women and diverse populations in general. And it might be a nice starting point for you if you're feeling uncomfortable with a certain group. Try the careers in physics lesson, because it really just opens up diversity across the board, and just looking at what are some ideas, what are some careers out there that you would never think having a background in physics could support.
Oh, okay. And that might be good for my physics students, I guess, if I could do that first.
Yeah, and if it goes really well, then
I could try this. Yeah,
for sure.
Well, thank you. That sounds good.
Yeah, and I do the careers in physics lesson within the first couple weeks of the school year, and I do the women in physics lesson maybe around like November in a typical year. It was December this year. because I want there to be a comfort and trust before we launch into that. Because if my students don't trust me or trust that it's a safe environment, then they're not going to open up the way that we need to. So I agree with Nicole that starting with careers in physics is an easier entry point.
Mm-hmm.
And I'd be happy to talk through the careers in physics with you anytime.
Okay, and that is both on the same,
Mhm.
on Step Up, they're both available. Okay,
Yes.
and we'll try to look at that.
Yes, for sure. And there is an online option for the careers in physics also. I don't know if you're doing in person or online or some sort of hybrid, but they have made it very, very smooth for an online option for careers in physics for this year.
Oh, okay, yeah, we're fully back in school. All students are back in school since the beginning of this semester, so.
And I do have to share, since I somehow managed to make my way into the official Step Up slides for this. This is an experience I had with a student last year who is currently in my AP Physics C Mechanics and Physics C E&M courses. She wrote me an email that day after school. She never said a word during class, but wrote me an email. Her family had been telling her for years that, women can't do math. And now she's looking at a major in like encryption technology type stuff and minoring in physics. And, so she's, moving into tech fields. And she told me that this lesson was like a key moment for her, which, just feels powerful to hear that. Anyway, and it is after 8, but I don't mind sticking around. I don't know what Melissa's got going on, but I can stick around.
I can stay around.
Well, I'm going to head out, but I do want to say this is great. This is exactly this would work awesome in my classroom. So I don't really have any questions or anything, but Jeremy, I know where to find you.
You do. So yeah, anything I can do to support or Melissa, and I can share with all of you. Melissa, everybody here except for Nicole is in the Intro to Modeling course that I'm doing with Ariel and Scott.
Nice.
So I can share with you contact information, so you can email me, or Melissa, can I give them your email?
Yeah, absolutely.
Okay, great. So, we'd be happy to support you with whatever you need in terms of implementing these things.
Awesome. Well, thanks so much for putting this on.
Yeah, thank you. I think I need to go too, so thank you.
You bet.
See you later, everybody. Have a good night.
Yep.
Good night.
You too.
Great joining you guys tonight. Have a good evening.
Thank
You
you for
too.
joining.
Thank you.
And thank you again for Melissa and Jeremy for presenting. And just a quick shout out, Nicole didn't want to do it, but Nicole is presenting in April, another Step Up session.
Yay!
Good night.
Okay, then I will stop the recording and